In this video, I'm going to talk about tangent and cotangent graphs. I'm going to start by talking about the parent function, so y equals tangent of x and y equals cotangent of x. And in order to explain what these graphs are going to look like, I'm going to talk about them in terms of sine and cosine. So y equals tangent of x, I can also write this as y equals sine of x over cosine of x if I wanted to write tangent in terms of sine and cosine, which we've been talking a lot about. I know that when I have a rational function, whatever's in the numerator, or whatever makes the numerator equal to 0, is going to be an x-intercept. So whatever x values would make sine of x equal to 0 are going to be x-intercepts. I also know in rational functions that whatever is left in the simplified denominator that doesn't cancel, and nothing cancels here, is going to give me vertical asymptotes. So it's going to tell me whatever x value makes the denominator equal to 0 is going to be a vertical asymptote. And those are two things that are important for me to know, the x-intercepts and the vertical asymptotes for a tangent graph. So I'll repeat that. Sine of x, when it's equal to 0, I know that I have an x-intercept at x comma 0. And those are for values. So x values, these are going to be angles that go inside of sine. So angles that go inside of sine that make sine of x equal to 0 would be, the first one would be 0. If I plugged in sine of 0, I would get 0. If I plugged in sine of pi, I would also get 0. So I'm thinking of sine is the y value, and I'm thinking on the unit circle. This is 1 comma 0, this is 0 comma 1, this is negative 1 comma 0, and this is 0 comma negative 1. So I'm looking for when the y value is equal to 0. So that would be here and here. So just 0 and pi and all their coterminal angles. So 0 and positive or negative pi, positive or negative 2 pi, positive or negative 3 pi, etc. So I'm going to have x-intercepts for the tangent parent function graph. I'm going to have x-intercepts at those x values. Then for cosine, for the denominator, I know when cosine of x is equal to 0, that's going to give me, like I said, vertical asymptotes at whatever x is. So the x values, or the angles that would make cosine of x equal to 0 would be pi over 2, plus or minus pi over 2. And we talked about these before on the first day when we were talking about cosine and sine. Plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. So these values here are going to be vertical asymptotes on the tangent graph. We don't have vertical asymptotes on the sine or cosine graphs, but we will have them on tangent and cotangent. For how I'm going to scale this, I'm going to scale it by pi over 2. Something I'm going to note is that for tangent graphs, the period is actually going to be pi for the parent graph instead of 2 pi. So the period I know for this is going to actually be pi. I'm going to scale by pi over 2, though. So, all right, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, and I'm just going to stop there. And then I'll go backwards and negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and negative 5 pi over 2. Then I'm going to draw these important things that I just found. So vertical asymptotes, I'm going to start there because that's what I start with when I was doing rational functions. So I'm going to put a vertical asymptote on pi over 2. I'm also going to put one on 3 pi over 2 and 5 pi over 2. So this is where I'm going to have vertical asymptotes for the tangent graph. I also have at negative pi over 2 and negative 3 pi over 2. And negative 5 pi over 2. Vertical asymptotes there. Then I know that I have x-intercepts at 0, plus or minus pi, plus or minus 2 pi. So I have one here, I have one here, one here, one here, one here. So those are my x-intercepts. Another thing that I know, so I'm going to go off to the side. I'm going to say some things. For when I'm finding the period for tangent graphs, I'm always going to take pi and divide by whatever b is. In this graph, or this equation, the b is 1. So really I'm taking like a normal period for this type of function and dividing by whatever b is. And I did that for sine and cosine as well. But a regular period for sine and cosine was 2 pi. So that's why I took 2 pi and divided by b to find the period. So that's one thing to note. Another thing to note is that maybe I should finish talking about cotangent first. I'm just going to talk about what the tangent graph looks like. Because the amplitude is 1, that's going to be how I find the other important points in the parent function. Tangent I know is going to be actually going upwards as I go from left to right. And so I'm just going to explain this quickly here, but I'll explain it more in detail later. But I'm going to be at, and I should label this graph, so I'll label every 2 things on the y-axis, I'll label them 1. So because I have an amplitude of 1 here, I'm going to have a point at -1 in between the vertical asymptote and the x-intercept. On the other side, so here, I'm going to have, because of the amplitude being 1, I'm going to have an important point here. So what these are going to look like is as I go to the left, I'm going to get closer and closer to the vertical asymptote, and as I go to the right, I'm going to get closer and closer to the other vertical asymptote. And this pattern is going to continue over and over, just like the sine and cosine graphs continue the same shape over and over, so do the tangent and cotangent graphs. So this is what tangent will look like. And that important point that I'm plotting is based off of whatever the amplitude is. If the amplitude was 3, I would put that important point in between the x-intercept and the vertical asymptote. I would put it at 3, or a -3. And so that's what the tangent graph would look like. For cotangent, I know that I can rewrite that as, because this is the reciprocal of tangent, I know I can write it as cosine of x over sine of x. And so what I can say is that, well, to get an x-intercept, I'm actually going to find what would make cosine of x equal to 0. So looking at like the numerator, what would make the numerator 0? It would be when whatever x value made cosine of x equal to 0, and then I know I would have an x-intercept if I had 0 in the numerator at whatever x comma 0 was. And in this case, we already talked about what would make cosine equal to 0, and it's these values here. So plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, etc. So those are the values that would make cosine equal to 0. And so these are going to be my actual x-intercepts in cotangent graph. So it's flipped from what it was in the tangent graph. And then I also know that sine of x, when that's equal to 0, that's going to give me 0 in the denominator, which is going to give me vertical asymptotes. So then I know I'll have a vertical asymptote at whatever the x value is. And for when sine of x is equal to 0, so for these values here, so 0 plus or minus pi plus or minus 2 pi, so 0 plus or minus pi plus or minus 2 pi, etc. So these values are going to be vertical asymptotes, every pi. Let's plot those. So let's plot the vertical asymptotes. So I have a vertical asymptote at 0. I have a vertical asymptote, I didn't scale my graph. So this is pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. This is negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and negative 5 pi over 2. And then I'm going to put the vertical asymptotes where they belong. So I have one at pi and one at negative pi. And then I have one at 2 pi, oopsies, one at 2 pi and one at negative 2 pi, And then I have the x-intercepts are at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, and negative 5 pi over 2. And the difference between tangent and cotangent is that when you have a positive coefficient, or the parent function, with no reflection over the x-axis, it's going to go downwards instead of upwards. So tangent went upwards as I went left to right. Cotangent goes downwards. Still, it has the same amplitude of 1, so it should be in between the x-intercept and the vertical asymptote should be a point at the amplitude, the positive version, and in between on the other end, it should be based on the amplitude, that important point, but negative version. And so this is what the pieces would look like in the cotangent graph. So this is what they look like this, and like this, and so on. And you just keep drawing. And one period would be one of those shapes that's repeating. So I said the period I always find by doing pi over b. For tangent, I know that the x-intercepts are, I know, most importantly, I have an x-intercept at the origin. So I have an x-intercept at the origin. Helpful for me, so it'll always be at the new origin, whatever that is. And then for cotangent, the thing that is good to remember is going to be at the origin is a vertical asymptote. So we always care about like where we're starting. That's going to help us when we're dealing with transformations. So for cotangent, I actually have a vertical asymptote at the origin. And these are going to be helpful ways for you to remember the difference between tangent and cotangent when you're doing transformations, especially. A is going to tell you, like I said, it's going to tell you important points halfway between the x-intercept and the vertical asymptote. So it tells you the important points halfway between x-intercept and the vertical asymptote. The other thing I want to note for both of these graphs is that the x-intercept is halfway in between the vertical asymptotes. So the x-intercepts are halfway between the vertical asymptotes. If you ever forget where the x-intercepts are, that's where they are. If you ever forget where the vertical asymptotes are, you can also use that information as well. So these are the things that you need to know. For the transformations, we're going to talk about the steps for doing making graphs based off of the parent function, but that have shifts and reflections over the x-axis and different amplitudes, etc. The first thing that you're going to do is you're going to find the period. So the first thing you're going to do is find the period. And I know that the period in the case of tangent and cotangent is going to be pi divided by b. So in order to find what the period is, I'm going to do pi divided by b. The second step is to scale the x and y axis. So scale x and y axis is the next step. You're going to be counting by, instead of, well, actually, same thing that you would have in the case of sine and cosine. You'd take the period and divide by 4. So count by whatever the period is divided by 4. I guess I'll highlight that in orange as well. And then the next thing that you're going to do, so the third step, is you're going to draw new x and y axes. So draw the new x and y axes based on the horizontal and vertical shifts. So draw the new axes, which is based on horizontal and vertical shifts. And vertical shifts. Okay. And then for the fourth step, after you do that, I like to color code everything. So horizontal and vertical shifts. The horizontal shift is going to be like where your new shape starts. or the period is starting, and then the vertical shift is going to be where the new middle is. For step 4, you're going to draw your first vertical asymptote. So draw where your first vertical asymptote is. For tangent, you can do this in a different way if you want to. I'm telling you to do it in this way, but you can do it however works best for you. For tangent, the first vertical asymptote is going to be, actually, maybe I should do, no, let me, yeah, okay. For tangent, the first vertical asymptote is going to be pi over 2b away from the new y-axis, left and right. So away from the new y-axis, left and right. So you can draw both of those in, both the one to the left and to the right. They are going to be pi over 2b away. For cotangent, the first vertical asymptote is going to be at the origin, like we already talked about. So I already know it's going to be at the origin. So on the new y-axis. So the vertical asymptote is on the new y-axis. All right, after I draw the first vertical asymptotes, I'm going to draw the other vertical asymptotes every period. So I'm going to base it off of what the period is and then count that much away and draw another vertical asymptote. So after I draw the first vertical asymptote, I'm going to draw the other vertical asymptotes every period. So one every period. Make sure the length between each vertical asymptote is 1 period. And this is how you find the period again. Number 6, step 6, is to draw the important points. So you're going to draw the important points. And you're going to have zeros in the middle of the vertical asymptotes. So zeros in middle of VAs, vertical asymptotes, on the new x-axis, wherever that is, not on the original x-axis, the new middle, wherever that is. And then you're also going to draw points where y is the amplitude, or points where you're showing the amplitude in the middle of a zero and a vertical asymptotes. Points based off amplitude, and those will be in between, or in the middle of each zero and vertical asymptote. Okay, and then the last thing, you should keep in mind that you should be going upwards. Well, you need to be keeping this in mind when you're drawing the important points based off of amplitude. You should be going upwards for positive tangent and downwards as you read left to right for positive cotangent. All right, and those are the steps for drawing tangent and cotangent graphs. Let's try 2 examples. So one with tangent, one with cotangent. Example 1, that's going to be, it's a tangent equation. I'm going to pull the important information from the graph. So the first thing that I see is that I have an additional, what's extra than would have been in the parent function. I have that 2 in front. That tells me that the amplitude is equal to 2. So I know the amplitude is equal to 2. That's something I need to know. I also know that I have, the b has changed from 1 to 3. The coefficient for what's inside of tangent has changed. And so I know b is equal to 3, which means that the period is equal to pi over 3. So that's going to be helpful for me, knowing the period is pi over 3. That's going to help me create my scale. I don't have any other additional things besides that, and those are the 2 things that I really need to know all the time, even if I don't have a transformation for them. And then I'm going to create my scale. So I know I'm going to be counting by whatever pi over 3 divided by 4 is. So that's pi over 3 times 1 over 4 or pi over 12. So I'm going to be counting by pi over 12. So the scale is going to be pi over 12, and then 2 pi over 12, which is pi over 6, and then 3 pi over 12, which is pi over 4, and then 4 pi over 12, which is pi over 3, and then 5 pi over 12, which does not simplify. So I'm going to leave that like that, and I'm going to, next thing I'm going to do is I'm going to scale my axes. So I have pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, and then the reverse. So negative pi over 12, negative pi over 6, negative pi over 4, negative pi over 3, negative 5 pi over 12. I also want to scale the y-axis. So every 2 spaces I'm going to make worth 1. So I'm going to do like this. And then I'm going to start plotting the next step. So step number 3 is to draw the new x and y axes. Fortunately, I do not have any horizontal or vertical shifts, so I can skip that step and go to number 4, which is to draw the first vertical asymptote. So the first vertical asymptote, I have a tangent graph here, is going to be pi over 2b away from the new y-axis. So I know for tangent, and if this is more helpful for you, you can draw the x-intercept like you know is going to be on the origin or on the new origin, which happens to be the old origin in this case. Then I know to find pi over 2b, I'm going to do pi over 2 times 3, which is pi over 6. So I know that pi over 6 to the right, I'm going to have a vertical asymptote. And pi over 6 to the left, I'm going to have a vertical asymptote. So that's what I meant when I said this statement here. Then I know I'm going to count another pi over 3 away from that. So because of how I scaled the graph, it should be 4 tallies. I'm going to put oh wait, that's not even on the line. What am I doing? Whoopsies. That should be on 5 pi over 12. Is that 4 away? 1, 2, 3, 4. Nope, just kidding. It's not 4 away. That is not 4 away. It would be here. Off right here. This would be where I would have another vertical asymptote. Sorry, not 5 pi over 12. I need to have 4 sections. And if I scaled by like 1/4 of a period, then I would be counting 4 sections, and that would be my next vertical asymptote. So I also have one over here as well. And now I'm going to put in the important points. So I have in the middle of 2 vertical asymptotes is going to be a x-intercept. So I'm going to put those in where they belong. And then I'm going to put in the important points. So this is tangent, so it should be going upwards as I go left to right. The amplitude is 2. So in the middle of here and here, I have at -2 a point. So that it will be going upwards, because in between here and here, I should have a point at +2. As I go to the left, I'm getting closer and closer to the vertical asymptote on the left. And as I go to the right, I'm getting closer and closer to the vertical asymptote on the right. I should also have a point here and a point here. And then do the same thing here. And this shape should be repeating. So I should also have a -2 here and +2 here. And I see that shape repeating over and over. I'm checking that it's going upwards for positive tangent. This is positive tangent, and it is going upwards like it's supposed to. For example 2, this is a cotangent graph. Let's look at the extra stuff we have. First, we have a reflection over the x-axis, which means this is actually going to be going, instead of downwards, it's going to be also going upwards as I go left to right. So the shapes that's going to be repeating is that. That's what I'm going to keep in mind when I'm creating this. I have the amplitude is equal to 4. I need that for my important points. I have the b value is 1/2. If b is 1/2, then I know that the period is equal to pi divided by 1/2, or pi times 2. So the period is 2 pi for this. And I'm going to need that to scale my graph. Well, we've done this a million times. We know if the period is 2 pi, I know I'm going to count by, oh wait, you had additional stuff on your thing. So let me fix this. I added stuff, right? So I added, this should be x plus pi over 2. And then I have plus 1. Okay, I'll fix that later. But I know for the period, I'm going to be counting by pi over 2. So the scale is going to be pi over 2, comma, pi, 3 pi over 2, pi over 2. So we've done that so many times. This is 2 pi over 2. This is 4 pi over 2, and those simplify. But I'm counting by pi over 2 for that period length. I also know that if I have plus pi over 2 inside, I'm going to be going left pi over 2. So now I'm going to be going left pi over 2. That's something I need to keep in mind. And I'm also going to be going, because I have this plus 1 on the outside, up 1. So my x-axis and my vertical axis are going to change. Before I put those new axes in, I'm going to label this graph. So this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi, and this is 5 pi over 2. Then I have negative pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, and negative 5 pi over 2. And I'm going to first put my new axes to see where my new start is, or my new origin is. So I have up 1, so everything goes up 1. I did not scale my x-axis. Should I scale it? Yeah, like that. My y-axis, I did not scale, and now I did. And then, so everything's going to move up 1. So I'm going to move everything up 1. So my new x-axis is at 1. I know everything moves left at pi over 2 also, so I'm going to be putting my new y-axis at that place. Because this is cotangent, I should have a vertical asymptote here, so I'm going to, at the new y-axis, and so I put it there. And then I need to count a period away. A period is 2 pi, so I should be, or 4 tallies, 1, 2, 3, 4. I'm right here at 3 pi over 2 is another vertical asymptote that I have. I also, if I go backwards, and you should be always including 2 periods, which we'll be able to do on this graph, I'm counting 1, 2, 3, 4 to the left, and this should be my other vertical asymptote that I have. In between these 2 vertical asymptotes that I drew should be, or in between this one and this one should be a x-intercept on the new x-axis, so it should be at negative 3 pi over 2. Also in between this one and this one, there should be a x-intercept on the new x-axis, which should be at pi over 2. The important points, because I have the reflection over the x-axis, should be looking like tangent. I know that the amplitude is 4, so I'm going to count 1, 2, 3, 4 down, and I'm going to have a point here, and I should be counting up. I'm not going to be able to fit that on the graph, so I'm just going to put that important point and just sketch the other side. I also have for in between here and here, I have another point at negative 3, and so this is what this graph would look like.